Okay. This will be lesson 8.2, yeah? Lesson 8.2.
Yes,
That means second segment of lesson 8, okay? Lesson 8.2. Now, yesterday we did some ions, yeah? Negative ions. I call them compound ions, or they are also called
cathode.
polyatomic ions, okay? They are called polyatomic ions. What is poly?
Many.
Many. Or multi-atomic ions in it. Yes, like NO2 minus. Why it is minus? 1 minus, it's not 2 minus, 3 minus. Do you know?
Because the amount of electrons lost.
Hmm?
The amount of electron gained, sorry.
No, I want you to understand this.
Ion bond.
No. Still, yesterday I told you why OH is minus. You forget about that.
Because the bond.
Why is it? Yes, when they have a covalent bond,
Yeah.
there's still one electron left, and that electron has a charge of minus.
Yes.
Okay, yesterday I demonstrated that.
Cancel electrons.
Yeah, so I don't want you to sit here and do like an inter. Okay? Look, I said our oxygen, okay? It bonds with hydrogen. Hydrogen has one here, oxygen has one here. But oxygen, atomos cell, how many electrons does it have?
6.
Hmm?
6.
6. Now look at it. If it forms a covalent bond with hydrogen, it appears hydrogen contributed 1, and one of oxygen is that. Okay? Now, how many? This will be K cell for hydrogen, and this will be L cell for oxygen, isn't it? Okay? Make it red. Now, we say electrons are in pairs. Okay? In the K cell, the maximum it can take is 2. So I look here. The K cell, the maximum it can take is 2.
Yeah.
The L cell, the maximum can take 8.
8.
Now look, how many are here? 7.
Yeah.
So if it is 7, it means there's one electron which has one charge in it.
Charge, yeah.
Yes, that's why
The whole thing has a charge now.
the whole thing have a charge now,
Yes.
OH minus. Although it's a polyatomic ion, but it has a charge.
But it wouldn't have a charge if it was OH2 minus.
If I told another hydrogen come here, you understand, and provide another electron, that will be water then. Okay? Look at that. Let's look at that.
So if it was OH2 minus.
Let's look at that scenario, please. Let's say another oxygen come here.
Hydrogen.
It provide hydrogen come here. It provide its one electron,
Yeah.
and the last electron of oxygen, yes? So this will be 2H2, two hydrogen and one,
Oxygen.
what do you call this?
Water.
This is called water. There will not be any charge. Okay? But hence, since there is one hydrogen missing in a previous scenario, the charge was minus. That's why it's OH minus. These are called polyatomic ions. And if you want to understand reactions, you must know these how things work, because I'm going to give you a simple way, which I told you is not in any textbook, of determining how will the compound look like. Okay? How sodium chloride, but sodium sulfate will be like this. Why? That's why I want you to understand, not you learn it blindly like that. Okay? You just see it and assume it like that. Until the rest of your career, you will know sulfate is 2 minus, but you don't know why. You understand?
Yeah.
Maybe your PhD, you will know why. Now let's look at NO2 minus. 2 minus, yes? Okay? Nitrogen is N2 minus also. Okay? Now, NO2 minus means 1 nitrogen plus 2 oxygen in it. Because oxygen is 2 minus, nitrogen is also 2 minus. Are they sorry. Nitrogen is 5 minus. Nitrogen is in group. Which group is nitrogen?
Group 5.
Hmm?
Group 5.
Group 5. Okay. In group 5. Okay. Nitrogen have 5 in its atomic cell. Okay? Now, look at this. Is N2 in it? That means 2 minus N5 minus. Okay? Nitrogen. Okay? So, this means this will be minus 4, 5, minus 5. 4, because 2 of that in S, that will become minus 4 plus 4 equal to minus 1. That's one. NO2 is 1 minus. See, that's why NO2 is 1 minus. Musa, we'll sit down and do this properly, yeah? Because we don't have much time in online lessons, yes? We look at another famous polyatomic ion, CO3, which is 2 minus. Okay? You should know that this is 1 carbon plus 3 oxygen in it. So if each of them is 2 minus, that will be 6 minus in it.
Yeah.
Okay? And carbon is what? 4 plus. Carbon is 4 in it.
Yeah.
So 4 minus 6 is equal to minus 2. That's why CO3 is 2 minus. The same thing applies to all the polyatomic. You can find out why they are like that. Okay? Now, there's balancing equations. Yes? Balancing equation. Let's go to balancing equation. Balancing equation. We will do 2 lessons on this, okay? Now, if you look at the group 1, you can group some of the elements and give them their valences. The valences is the charge when they become ions, okay? Now, let me give you a comprehensive list. Group 1. Group 1 here. You have sodium when ion is plus, potassium ion is plus, and silver ion is plus. Now, group 2, okay, copper is 2 plus, lead is 2 plus, magnesium is 2 plus, calcium is 2 plus, zinc is 2 plus. These are the famous ones. And there's ion 2 and ion 3, 2 plus, yes? And group 3, ion 3 plus, there's 2 types of ion 2 plus and ion 3 plus. And aluminium 3 plus is Al, not capital L, okay? And then ammonia, okay, plus 3 plus, yeah? Okay, now, these are the common ones we'll be using in the GCSE exams. So you must know them.
Yeah,
okay?
I read that yesterday.
You read about that, yeah?
Did you read it?
Yes. So you must know them.
Ammonium sulfide.
Yeah, exactly. So most of the the problems we'll be solving will be involving these ions. Now, first of all, if I tell you H2 plus O2 is H2O. Now, why is H2O not HO? That's what I want you to understand. Now, the example I gave, okay, the example I give is, imagine you have a combination of 2 elements, okay? Or atoms of 2 ions on 2 elements.
Compound.
A compound, yes. A combination of 2 elements here. One is X and one is Y. Okay? Element X and element Y. Imagine this one, when it becomes an ion, that means it loses electrons, it will become 3 plus. And this one, when it loses electrons, it becomes 2 minus. Because a minus and a positive will react in it.
Yeah.
Okay? In a ionic compound.
Yes.
Pay attention, please, Mustafa.
Yeah,
Okay? Now, what compound will it will form? Is it XY or X2Y3 or X2Y2? X2Y2, okay? Y2. Now, this may be difficult for a person who is just studying chemistry. This may be difficult for a person who is just studying chemistry.
New person.
Can you put your attention here, please? Okay. The simplest thing I ask, instead of you saying, let's find the LCM of this, because this is 3 and 2. Find the LCM of this and then divide. No. That will be a long way to do it. What happened is, these two elements, the compound that will be formed, I say you exchange the valences. Okay? This 3 will come to the Y, and that of Y will come to X. You understand? I mean the valences. These are called the valences. Okay? It's called the valency. That's the charge. So this compound that will be formed will be X2 and Y3. Take note of that. Okay? X2 and Y3. Example, aluminium 3 plus and chlorine 1 minus. Okay? And another one is magnesium 2 plus, okay, and sulfur and hemi minus.
One.
Sulfate.
One.
No? 2 minus. That's why I say I'm going to be asking you this. You have to be studying this. That's why I said. I asked you should be studying this.
Oh yeah, sulfate 2 minus sulfide.
Yeah. What about nitrogen?
Nitrogen is.
It's not nitrogen, it's nitrate. It's 1 minus. You must memorize that, okay? Yeah. If you want to continue, you have to memorize that. Now, simple. The compound that will be formed, they will exchange valences, yes? So that aluminium will be 1, because it's 1 minus in it. Aluminium will be 1, and chlorine will be 3. Here, they exchange valences. Okay? Magnesium will take that one. Only 1 magnesium.
Yes.
Chlorine will take that one. Sorry, nitrate will take that one.
6.
No? That's exactly.
Because the 2.
Yeah, you got 2, but you don't put it 6 like that. Because if you do 6, it's only oxygen, which is 6. But the whole nitrate is a compound, isn't it?
Yeah.
It's called a polyatomic ion. You must know that is polyatomic ion, okay, or compound ion. Polyatomic ion, okay. So the whole of that will be in a bracket. Because the whole minus, I demonstrate why it is minus. It is the whole of that minus and 2, because 2 of that we needed for 2 positive in it. Okay? You have 1 magnesium 2 plus. You need 1 minus for 1 nitrogen, another minus 1 minus to make this 0. You see? Yeah. So it's the whole polyatomic ion 2. And if you are doing balancing equations, you're going to put the polyatomic ion as its own, not nitrogen by itself and oxygen by itself. And I will show it in one example. Okay? Now through this, we can do if we know that how these things are formed, this is very, very important, because the topic we are going to do, atomic mass number, relative mass number, and some equations will do, you have to know this. The examiner may not give you the full equation. He will ask you, when hydrogen reacts with oxygen, it produces a compound. What is that compound? You have to know that it is, when hydrogen reacts with oxygen, it will be, because hydrogen is 1 plus, oxygen is 2 minus. So the exchange valence is in it. This becomes H2 and 1 O. That's why water is H2O. Yeah. I don't think you understand it.
I understand it.
Because you need 2 hydrogen, all plus, to cancel 2 minus in it. Yeah. So +1 + 1 - 2 equals 0. Okay? Now, there are various ways of balancing this type of equation. It's simple. Some people, these are called the reactants in it. Yes. Because they are the one reacting in it. Reactants in it. And this is called the product in it. Yeah. Okay? So, they put the reactant hydrogen and oxygen in it. Yeah. Here, the product also is hydrogen and oxygen. Now, how many hydrogen do we have? Two. Two hydrogen. How many oxygen do we have? Okay. Now, in this side, on this side, hydrogen is how much? Two. Oxygen is equal to one. So there's an anomaly. There's an anomaly. What's an anomaly?
Like something that's a mistake.
Unusual, yes? Because there's a law of conservation of mass. Have you ever heard about this? Conservation of mass. You did it in physics? Yeah. What does it mean in physics?
No, we haven't done it yet, but I've heard it.
Then the atoms cannot be created or destroyed.
Oh yeah, atoms cannot be created.
Okay, so the number of atoms of the reactant must be equal to the number of atoms of the product also. So you cannot just create another element and say chlorine, add chlorine here, but chlorine is not here. You know what I mean? What you have here must be equal to what is here. The number of atoms for the reactant must be equal to the number of atoms for the product. That's why you have to balance. You have to balance because it cannot be destroyed. Only in an open reaction. What's an open reaction? Open reaction and a closed reaction. An open reaction is when the apparatus are set. They are not closed. So when one of the product is gas, it will go into the atmosphere in it. So then the reactant will not be equal to the products because some of the elements or some of the atoms or some of the compound that is formed evaporates. But if you close it, nothing can go in, then the sum of the product must be equal to the sum of the reactant. Okay? Yes. That's what the law apply in balancing equations. Now, obviously, our hydrogen and our hydrogen reactant, hydrogen product are equal. You understand?
Yes.
Okay. So, if that happens, we say, okay, that's okay then. But what about oxygen? Oxygen is 2 for the reactant and 1 for, we multiply this by 2, okay? We make it 2.
No thing. Would you add a 2 in front of the H2O?
Hold on, wait. That is what we do last year when I was GCSE, we do. I want to demonstrate. I'm doing it online for people who may not understand, okay? Now we put 2 here because oxygen on the reactor or the product side, we should make it 2. We cancel the 1 and make this 2. But if we make this 2, we have a problem because hydrogen will be 2 times 2, which is now 4 in it. 4 in the product, but 2 in the reactant. Yes. The only way we can make this 4, multiply this by 2 in it. Make it 4. Now, the only way we can do is multiply this by 2. Now you can see 4 hydrogen, 4 hydrogen. Okay? 2 oxygen, 2 times the 2 oxygen. Yes? When we are putting these are called in mathematics. What is this in mathematics? 2. What is it called? What is it called? Coefficient. You know your maths. Coefficient. Okay? Something that multiplied by the 2 times x. 2 is the coefficient of x. Because 2 is multiplying x. We only change the coefficients. Okay? We only change the coefficients. We only change the coefficients. We don't change these numbers. We don't change them, okay? We don't change this one. Because this is say the 1 molecule of oxygen or 2 oxygen atoms combine a covalent bond, a molecule of oxygen. So we don't change that. We change only the coefficient of the numbers. Okay? This is one example balancing equation. Now, we will do some very, very, very difficult ones. And one of them, because we have less than 20 minutes, okay, I don't do a difficult one because you take time to solve it. You know methane, okay? What is methane? I explain what is methane. What is methane?
Gas.
It's a gas, yes, but it's hydrocarbon in it.
Yeah.
Which you have in use it for gases, in burning in it. When it is fully burned, it produces carbon dioxide. And carbon dioxide is what type of gas?
Dioxide.
Dioxide, what type of gas? Type of pollution.
Yeah, pollution. Yeah.
It causes
It's a greenhouse gas.
greenhouse gas. It's a greenhouse gas. Brilliant. Because it can cause what?
Global warming.
Global warming. Okay, pollution, yes, environmental pollution. When the methane is completely burned or completely oxidized, oxidation means burning, innit?
Yeah, basically.
Mean adding oxygen. We are going to do oxidation and reduction. Oxidation can mean adding oxygen or losing electrons. Okay? 21 minutes. Okay. Now, when methane is completely burned, it produces carbon dioxide. But if it's not completely burned, it produces a poisonous gas called carbon monoxide. Okay? Carbon monoxide. Okay? Now, two of these it can be like this, plus oxygen will give you carbon dioxide plus H2O. That's why petrol is a hydrocarbon. When it's burned, you can see coming from the carb burner, water coming out, yes? But when it's not full oxidation, full burning, it produces carbon monoxide plus H2O. Now to balance this. This is not an easy one, okay? I'm going to leave this tomorrow. We do more balancing equation, okay? We're going to do more balancing equation. They will be that it look innocent, but it's not. Okay?
You have to add 2 in front of everything.
No, that won't. No. Because if I add 2 in front of everything,
No.
there will be 8 carbon here, innit?
Yeah.
Sorry, 8 hydrogen and 4 hydrogen here.
No, you have to add a 2 there. A 2 there.
Product and carbon,
You have to
hydrogen, oxygen.
You have to have a 2 on everything except the
Carbon,
O2.
hydrogen, oxygen, this side.
Yeah.
Okay? Right now we have how many carbon? 1.
Yeah.
How many hydrogen? 4. How many oxygen? 2. But in this side, how many carbon? 1. It appears it is balanced, but be careful, it's not. How many hydrogen? 2. How many oxygen? 2. So it appears the only anomaly is hydrogen, innit? Okay? Hydrogen, yes. So the only anomaly is hydrogen. So we'll simply put 2 here, innit? To make this 4, we put 2 here, innit? Multiply this by 2 in it, and we have 4 in it. But if you do that, the conundrum, the oxygen will now be 3 in it. 2 times 2, 3 in it. Okay? And we can make this 3. You understand? We can make oxygen 3 in it. Do you understand?
Yeah.
We can make it 3. The only way we can make it 3 we make this 1.5. Then oxygen is 3 here. Okay?
No, it's 2 there.
It's 2 there.
That's 3, yeah.
It's 3. But now, when balancing equation, you can have 1.5. You can't have 1.5. Do you get it? You can't. Okay? So the only other way is we multiply everything by, to get everything by 2. Okay? When we everything by 2, this becomes 2. Okay? This becomes 3 then. Okay? And this will be 2, and this will be, multiply this by 2, it become 4, innit? Yes. Then this will become 4. That's why I say this one is not as innocent as you think. Now let's count. How many carbon? 2, 2. Okay, hydrogen, 2 times is 8, 2 times 8. Oxygen, 2 here, okay, 4 here, 6, 3 times 2, 6, so it's balanced. Okay, so it's balanced. Do you get it?
Yeah.
So this one is not as innocent as this, and it can become an exam. Okay, so we're going to do a lot of balancing equations, yes? Because many students do have problem with this. When you finish the balancing equation, then we can go to ionic bonding, and then we come to metals, and then we come to neutralization reactions. And then we go on and on and on until we finish the syllabus. Okay? Now, subhanallah, bihamdi, subhanallah, al-azim, asadu la ilaha illa anta, astaghfiruka wa atubu ilayk. Okay? That's dua is if you, after talk or conversation, you make this dua. So that the mistake or the backbite, whatever you do, you can ask Allah for forgiveness. Okay? Subhanallah, bihamdi, subhanallah, al-azim, asadu la ilaha illa anta, astaghfiruka wa atubu ilayk.